Hi there, everybody. My name is Steve Hughes, and I am working on the digital tools homework assignment. So we were asked to choose one digital tool you currently use to facilitate student learning. My tool of choice is Desmos. Desmos is an online graphing, scientific, and matrix calculator. In fact, it's the only calculator that I use for all of the math classes that I teach. There's the link provided there for you guys if you want to go and check it out. Here's a fun fact for you. There's also animation, which is helpful for applications of linear and quadratic equations. And that is the lesson we're going to choose for today. So we were asked to choose a lesson, activity, or assessment for which you use the tool. And the tool I'm using is Desmos. The lesson is mathematical modeling. Here are the objectives for this lesson. We want to understand the question. We want to label the variables. We want to choose the formula. We want to create the model. We want to create a graph the model rather using technology, Desmos, and we want to be able to answer the question. So here's our setup. It says in the image below, the point xy is a first quadrant point on the curve of the indicated function. And right here is our function, just to make sure we're all focused on it right there. F of x equals 2 minus 2 over 25 x squared. As you guys can see, this is a quadratic function, which means the graph is a parabola. And in this question, we are asked to express the area of the shaded rectangle as a function of x and give its domain. All right, so we want to do a couple of things here. We want to express the area. I'm also going to go ahead and maximize the area of that box. We could add that to our list of objectives up here. In fact, let's go ahead and do that right now. Let's just go ahead and do it. Let's put in here, maximize the area under the function. Or I could say bounded by the function, right? F of x. All right, let's make a little typo correction here. All right, and we're good to go. So there's our boundary function. We want to find the area, and we want to express the area as a function of x. We want to be able to give its domain. All right, let's go to Desmos now, everybody. So I'm going to swap the screen over here with you guys. All right, and here we are in Desmos. All right, our objectives are given to us here. Understand the question. What are we doing? We are taking the function f of x, which I've typed in here for you guys right here in the middle of the screen. 2 minus 2 over 25 x squared. You guys can see this given in the black graph here. I could change this to make it a little bit easier to see for us. Let's change it to orange maybe, okay? All right, I'm going to turn some of these things off initially, some of these graphs. All right, so here is our function. This is our boundary function. And we were asked to express its domain. Well, everybody, in this particular example, if our function f of x is to be in the first quadrant, it has to start with x equals 0, right? So our domain goes from x equals 0 to wherever our function hits on the x-axis. That's the x-intercept. And why is that the case? It's the case because we're trying to provide the formula for the area. Let's go ahead and put this function in, okay? Let's go ahead and do this. All right, so there you guys can see I'm putting some things back in now. So why? This purple box right here in the middle is our area, right? That's the area we're trying to find under the curve, which is our orange. And the green function here, you guys can see this is my area function. If I go back up here, it says understand the question. We've done that. Label the variables. We've done that. X is our dimension. Y or f of x is our height. So x is the length. Y, or f of x, is the height bounded by the function f of x given to us by this parabola again. All right, choose the formula. The formula is an area, right? So right here is our function. Area equals x times f of x. X, remember, is our length. F of x is our height bounded by that function given to us earlier. All right, x has to go from 0 to 5. Why? Because we have to be in the first quadrant, first of all. And secondly, we can't go past where the function is 0, right here, right? The x-intercept. We can't go past there. Otherwise, there would be no area whatsoever, right? You can't have an area that's less than 0. So it has to be greater than 0 and less than 5. That's the domain, okay? We created the model right here. It's f of x times f of x. That's our area, length times width. All right, we have graphed this, and now we want to talk about maximizing it. So we've completed the first objective. What was it? It was to express the area of the shaded rectangle as a function of x. We did that right here, x times f of x. It's asked to give us the domain. We did that. Right here is our domain. All right, so we have completed those first objectives. All right, we chose our formula, area function, length times width. We created the model. We graphed our function, and now we're going to go about answering the question. The question is, how do I maximize the area? Well, everybody, to maximize the area under this curve, let's just watch. Watch what I do when I animate this. Okay, everybody, watch. And kind of guess with me as this is moving, kind of guess with me where you think the largest area is. Okay, watch. As my function moves, where do you think would be the largest area for that purple rectangle? Okay, the purple rectangle, where do you think would be the largest area? You say, well, it wouldn't be when x was 0, and it wouldn't be when x was 5, because both of those would be zeros. So it's somewhere in the middle. All right, that is 100% exactly correct. Now, I'm going to pause it here. And here's the next thing. In Desmos, okay, the Desmos will actually give you the vertex of the graph, that green graph, and that vertex will give you the maximum area of the rectangle. So where is that? It's right here. Here's the vertex of the green function. 2.886 is the value of x. What does that tell me? That tells me when x is 2.8867, let me see if I can run it out here a little bit. All right, I just went past it a little bit. It's right there. All right, on that dotted line x, that is the maximum area of my function. And how did I do that again? I found the vertex of my model. What's my model? The area x times f of x. I found the vertex of this model under this domain from 0 to 5. Okay, everything here has to be reliant or dependent upon the fact that we are inside of our domain. All right, let's go ahead and save this. All right. Now let's go and check to see where we're going next. All right, it said to graph the area function. We did that, we graphed it. Okay, now let's go ahead and describe our tool. This is part of our requirements for this assignment. So Desmos, as you guys can see, is a virtual calculator that teaches visualization by showing and animating the objectives. We've done that. Desmos, how is the tool aligned with the objectives? It's aligned perfectly with our objectives. It gives us area, it gives us room to take our notes. It gives us room to describe and write our functions. It gives us a picture of our function. It gives us a picture of our area. It matches our objectives exactly. Okay, one of our objectives was to graph the model using technology. We did that. Okay, we've done everything that's been asked of us here. All right, how is it suited for this lesson, activity, or assessment? Well, everybody, let's just think. Suppose I didn't have this access, this resource, this tool. What would I have to do? I would have to graph this by hand. There is no way by hand I could show, watch. Can I show animation by hand? No, I can't do that. I cannot show animation by hand. I cannot show my rectangle moving and giving me all those different options by hand. So Desmos maximizes my opportunity to give a visual lesson to all of the learners in this class. Okay, let's go on to step 3. It says reflect by explaining how or why did the tool work or didn't work to facilitate learning? How or why did the students achieve? How and why did the tool work or didn't work to facilitate learning? I can tell you from personal experience, I used this just last week in a class. Okay, the students loved it. They became aware of what was happening. They could see the domain, they could see the boundary, this orange function. They could see how the area of the function changes as it goes. Oh, let me say one more thing here. Watch, everybody. This value, watch. This purple value right here is AF of A, okay? That's giving you the area right here, green, I'm sorry, green. It's giving you the area, AF of A. You can see the area is decreasing, increasing. I know it's going fast, but you can see the area. If X is 3.3, the area is 1.12. All right, let's move it. If, if X is 2.3, the area is 1.5. If X is 1.2, the area is 1.88. And we found our maximum area to be right here, right at our vertex. When X is 2.886, and the maximum area is 3.49. That's what we found to be the case. Okay. All right. So AF of A is the, I'm sorry, these AF of A is going back up to my function right here. That's my function. A is the input. F of A or F of X is the output. Down here is my area, and that's right here in blue. Watch, right, as this changes, let's go again. Watch as this changes right here. There's our maximum area right there in blue. The dimensions are in green. The area is in blue. All right. And as I played this for my students last week, they absolutely loved it. How and why did the tool work or didn't work? It worked perfectly. It gave us an opportunity to not only take notes and write and understand, but it gave us a visual representation, and the students totally loved it. All right. How and why did the students achieve or did not achieve the learning objectives? The students learned them very clearly. They did excellent on them. Once I showed them the graph, once I showed them the function, once I showed them how to determine the maximum area and the dimensions of that function, they absolutely loved it. It was the best thing they'd ever seen. So they said. Why would you use the tool again? I use it every time. I use it all the time because there's nothing better in math than to take a complicated topic such as mathematical modeling and give the students an example where they can see it working in real time. All right. Was the tool activity assessment inclusive and accessible? If yes, how? Yes, it was. It's accessible to everyone in my class. I give every single person the links to it. I give them access to it. I give them my recordings of the video of it. And they all give rave reviews on how much they love it and how much it means to their class and their coursework. All right, so everybody, I have given you the resource, I have given you the tool, I've given you the objectives, we've cleared and completed the objectives. We've reflected on why it worked, and I'm going to post this video along with my work for you guys. If you have any feedback, I look forward to it. Thank you guys. We'll catch up in the class.